So student, here I have taken another example. So let's see how we calculate the transfer function of this signal flow graph. Okay, so first check how many forward path is there. So there are only one forward path, and this forward path is this, and this is named by P1 and indicated by red line. So the gain of the forward path is G1 into G2 into G3 into G4 into G5. Okay, next check how many loop are there. So there are 4 loop. Loop is indicated by L. So there are 4 loops. So there are L1, L2, L3, L4 name are given. Okay, so the loop gain is, first loop is G2 into H1, second loop gain is G4 into H2, third loop gain is G7 into H4, and fourth loop gain is G2 into G3 into G4 into G5 into G6 into G7 into G8. Okay, then check, is there two non-touching loop is there in this signal flow graph. So there are two non-touching loop is there, and this two non-touching loop are L1 and L2. There is 3 combination are there. So first combination is L1 L2, second combination is L2 L3, and third combination is L1 and L3. Okay, so here I have mentioned the loop gain, the product of these two non-touching loop gain. Okay, so next check, is there any 3 non-touching loop is present in this signal flow graph. So yes, there are 3 non-touching loop. Okay, so L1, L2 and L3, these 3 loop are non-touching. Okay, so here I have mentioned the loop gain. Loop gain means the product of the gain of these 3 loop. Okay, now we calculate the del. So del is basically, then this is the, here I express the del. So del is basically, del is equivalent to 1 minus sum of all individual loop gain. So here I have mentioned all this. Okay, then plus sum of the gain product of all possible combination of two non-touching loop. Okay, so here I have given, there are 3 combination of two non-touching loop. Okay, and then minus sum of the gain product of all possible combination of 3 non-touching loops. So there are 1 combination of 3 non-touching loops. So here in this way we express the del. Okay, then check del 1, del 2, del 1, because there is only one forward path. Okay, so check. Okay, so del 1 is equal to 1 minus G7 into H4. So if we consider this is our forward path, this is our forward path. Okay, and this forward path is not touching this loop. Okay, so L3 loop. So here 1 minus L3. Okay, so L3 is the loop L3. So the value of the L3 is G7 into H4. So del 1 equal to 1 minus G7 into H4, because this is our forward path, and this forward path is not touching this loop. So here put the loop gain of this loop. Okay, which loop is not touch the forward path. Okay, so see, so here we remove the first forward path, and we see this first forward path is not touching this L3 loop. So that's why here del 1 equal to 1 minus G7 into H4. Okay, okay, so you will find, so put the value means P1 del 1 divided by del. So actually transfer, what is the transfer function? C by R. Okay, so this is equal to P1 del 1 by del. Put the value of P1 and del 1 and del. Okay, clear? Now come to the next example. Okay, so here we have seen there are three forward paths. This example we have solved in previous signal flow graph example. Okay, so in that case we have seen there are three forward path. That's why here we put n equal to 3. Okay, so here p1 del 1 plus p2 del 2 plus p3 del 3 by del. So find the forward path. First forward path is this, indicated by red line. Second forward path is this, indicated by blue line, and third forward path is indicated by black line. Here forward path gain is mentioned. Okay, now calculate how. Now first find how many loop are there. So we have already seen there are 10th loop. Okay, so here I have mentioned all the loop gain, all the 10th loop gain. Okay, next check how many two non-touching loop is there. So there are, these are the combination of two non-touching loops. So here you see there are 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. There are 15 such combination of two non-touching loop. Okay, next check how many three non-touching loop are there. Is there any three non-touching loop? Yes, there are 4 such combination of three non-touching loop. Okay, so non-touching loop L1, L3, L5 are non-touching, then L2, L4, L6 are non-touching, then L1, L3, L6 are non-touching, L4, L6, L7 are non-touching. Okay, then how we'll find del? So del is nothing but a combination of del is nothing but del is equivalent to 1 minus sum of all individual loop gains. So here 10 loop is there. So here this is the this is the sum of the gain product of all loop gain. Okay, next plus the sum of the gain product of all possible combination of two non-touching loops. So we have seen there are 15 combination of two non-touching loop, then minus sum of the gain product of all possible combination of three non-touching loops. So we have seen there are 4 such combination of three non-touching loop. Okay, then we will find del 1. So del 1 is 1 because first forward path is touching all the loop. Okay, next so del 2 means in second forward path you see the second forward path is this. Okay, so this forward path is not touching this loop, and this loop. Okay, so here I have mentioned this 3 loop. Okay, so this 3 loop is not touched by the second forward path. Okay, and the del 3, so when we see the third forward path, this third forward path is also touching all the loop. So del 3 equal to 1. So what is the transfer function? So this is our transfer function. Okay, so here 3 forward path. Okay, that's why p1 del 1 plus p2 del 2 plus p3 del 3. Okay, and divided by del. So this is x8 is output, x1 is input. So put the value of p1 del 1 p2 del 2 p3 del 3 and del, and we find the transfer function of this system. So thank you student. Today here I have finished the Mason's gain formula, and we have seen how we calculate transfer function by using Mason's gain formula. Basically how we calculate the transfer function of signal flow graph using Mason's gain formula. So today I will stop here. Thank you.